In this video, we'll continue to look at integrating indefinite integrals using u-substitution. If you've not already done so, press pause to copy down these steps for u-substitution. When you're ready to continue, press play. Our first example is to evaluate the integral of x times the cube root of x plus 4 dx. Our first step is to choose a value for u in terms of x. So we're going to choose the radicand and do the substitution. U is equal to x plus 4. Then the next step is to take the derivative of this equation. So I have du is equal to dx. And then because we have this extra factor of x right here, I need to manipulate this equation and find a value for x that I can use in my substitutions. So solving that for x, I get x is equal to u minus 4. And I'll do that, use that substitution as well. All right, our original problem I have written right here. So if we do our substituting, in place of the x factor here, I'm going to write u minus 4. And then I have the cube root of x plus 4, which I will substitute and make it the cube root of u. And then in place of dx, I'll just put du. Now I have an expression that's all in u, but I really need to simplify it some before I integrate. So I'll write my cube root with an exponent of 1/3, and then distribute that u to the 1/3. So now I have u to the 4/3 minus 4u to the 1/3. Just to integrate this expression. And when I increase my exponent by 1, I have u to the 7/3. So dividing by 7/3 is the same as multiplying by 3/7. So I have 3/7 u to the 7/3 minus, and then my 4 times, and then the integral here is u to the 4/3 divided by 4/3, which is the same as 3/4 multiplied by u to the 4/3, and then plus a constant. Now I make my substitutions back in place of u. I have to put back in my x plus 4, and the 4's cancel here on this product, so I just have 3 times the quantity x plus 4 to the 4/3 plus my constant. My next example, I'm evaluating the integral x divided by the 4th root of x plus 2 dx. So first step is to choose a value for u in terms of x. So I'll let u be this quantity that's under the radical. So u equals x plus 2. When I find the derivative of that, I get du is equal to dx. And then I also need to solve this equation for x so that I can have a substitution for the x up here. So I get x is equal to u minus 2. Now I'm ready to make the substitutions. In place of x, I'll put in u minus 2. And then I have the 4th root of u in the denominator. And then in place of dx, I'll put in just du. All right, I'm going to write this radical as u to the 1/4. And then I can simplify this by splitting this into 2 separate terms. So So the first term will be u divided by u to the 1/4. And remember, when you divide, you subtract the exponents. So the first term simplifies to u to the 3/4. And then this second one, -2 over u to the 1/4 power, I can just write that exponent with a negative exponent, and then it'll be u to the -1/4. Right, now I'm ready to integrate. The new exponent here is 7/4, so I have u to the 7/4 divided by 7/4, which is the same as multiplying by 4/7. And then this one, when I increase this exponent by 1, I have 3/4. So I have a -2u to the 3/4 divided by 3/4, which is the same as multiplying by 4/3. Now I need to sub back in place of u. So I have 4/7, and then in place of u, I'm going to put back in my x plus 2. Here I have 8/3, and then my x plus 2 is put back in for u, and then plus a constant. Our next example, we're asked to evaluate the integral of cosine to the 4th theta times sine theta times d theta. Well, my power here is cosine theta raised to the 4th power, so I need to choose a value for u in terms of theta this time instead of in terms of x. But I'll let my u be cosine theta, and then I'll have u to the 4th power here. So u is equal to cosine theta. Take the derivative of both sides, and I get du is equal to a negative sine theta d theta. Now I just need the sine theta d theta because that's all that I have back here. So I divide both sides by -1, and now I'm ready to make my substitutions. So my cosine theta is u, so I have u to the 4th power. And then my sine theta d theta, I can replace that with a negative du. Now the negative sign I can bring out in front of the integral. So I'm integrating just u to the 4th power. And when I integrate that, I have u to the 5th power divided by 5, which is the same as multiplying by 1/5. The negative is still out in front here. And then I have plus a constant. So then we're just ready to sub back in, and we have a -1/5, and then cosine to the 5th theta plus my constant. My last example is to evaluate the integral of secant 2x tangent 2x. Well, I know that the integral of secant theta tangent theta is the same as secant theta. So I just need to make this argument, instead of 2x, I need to make that a single variable. So that'll be my u-subtitution. So I'm going to let u equal 2x. When I do a derivative on that, I have du is equal to 2 dx. So that I have something to sub in for dx, I divide both sides by 2. So I have 1/2 du. Now I'm ready to do the substitution. So in place of 2x, I'm going to put a u. So integral secant u, and then tangent u, and then in place of dx, I'm going to sub in 1/2 du. Can bring my 1/2 out in front of the integral, and I have just 1/2 integral secant u tangent u times du. Now when I integrate that, my 1/2 is still out in front, and that's secant u plus constant. And all I need to do now is sub back in. What I have now is 1/2 secant of 2x plus a constant.